In this section, I'm going to show you how to, first of all, derive Newton's method, what Newton's method is used for, and then we'll show some example problems as to how to use Newton's method. So first things first, let's go ahead and define what Newton's method is going to be used for, okay? And it's going to be used to approximate the solutions to equations, or the zeros of functions. So it's used to approximate the zeros of functions or the solutions to equations. All right. And a lot of times there's equations that can't be solved. Okay, so for instance, let's say we had this equation like ln of x minus sine of x plus 1 equals 0. Okay, well, there's no analytic way to be able to solve this. And so what we're going to be doing is we're going to be using Newton's method, and we're just going to be using a calculator basically to find it. It's something called a numerical method. And a numerical method is any method that does not use any sort of algebra to be able to solve it. All right, so numerical method, usually like a calculator type of method. So let me derive the formula so that way you can kind of see where this Newton's method comes from. So let's say we have a function that's continuous, and I'll just use something like this. All right, so this is our continuous function f of x. And let's say for some reason I'm interested in the solution to this equation, maybe right here. Okay, now notice it has a whole bunch of zeros. Okay, so this is like a zero of the function. So what we can do is we can approximate that. All right, so maybe we don't know what that solution is. So let's just approximate it by making a guess. All right, and I'm going to call this guess right here. Let's call this x naught. And obviously the point for the y would be f at x naught. And let's say we were to equate the tangent line at that point. Okay, so we would find the equation of a tangent line. And notice what happens is that we get an approximation of the zero. Now it's not exactly, but it's pretty close to it. Right, so this is our equation of our line. Okay. And let's call this point x1. Right, so this is going to be the point x1 comma 0 because it's an intercept. Right? And if we were to try to find the equation of the slope through that line, well, remember we have our equation y2 minus y1 over x2 minus x1 is equal to m. Okay? And let's just call this, let's call this x2, x1, and let's call, or y1, or y2, excuse me. And let's call this point x1, y1. All right, and so we can just plug in, and we know that the slope is really f prime at x naught. Okay, so remember, to be able to find the slope at a specific point, you just take the derivative of the function and you substitute the value back in. So we could actually replace this with 0 minus f at x naught. Okay, so this is y2 minus y1 divided by x2, which is x1 divided by x naught. And that's going to be equal to f prime at x naught. Now what we can do is we can multiply both sides by x1 minus x naught, and then we can divide by f prime at x naught. All right, so let's just do a little bit of algebra, and we're going to get the opposite of f at x naught divided by f prime at x naught, and that's going to be equal to x1 minus x0. And where's the guess? Well, the guess that we want is actually going to be the point x1. All right, so remember, this is the point x1. So if we were to solve for x1, we would be able to get the guess of the equation. And so let's just add x naught to the other side. So we're just going to take this guy over, and we're going to get x naught minus f x naught divided by f prime x naught is going to be equal to x1. So in other words, we can guess the solution. So the guess is x1. But what's it from stopping us to doing that process again? So what if for some reason we now took the new guess, which was x1, and we got another equation of a tangent line, and we would get even closer. All right, so now we would get another point, x2. So let's call this point x2, 0. Right? And now what we're seeing is we're just repeating the process again. So we're going to end up now, we're going to use the exact same equation, except we're going to replace, and we're going to say now the terminal point is going to be x2. So this is going to be our x2, y2, and this is going to be our x1, y1. And we're just going to plug that into our formula. And so this is now, instead of x naught, it's now on the function. All right, so we're just replacing this now, because remember what we did was we dropped that orange down, and the orange is right here, so it's actually on the function. This is now f at x1. All right, so let's just go ahead and do this one more time so I can illustrate where the formula is coming from. So finally, remember our formula, y2 minus y1 over x2 minus x1 is equal to m. Now m this time is the slope at x1, right? So we're trying to find the equation of the tangent line, and the point that we have is the one that's on the curve, which is this x1. Right? So we're going to have, so if we plug this into our formula, we're going to get that we're going to have 0 minus f at x1 divided by x2 minus x1, and that's going to be equal to our slope, which is f prime at x1. And we can solve it the exact same way that we just did. And hold on to this, all right, because that's important. And so what we're going to do is we're just going to multiply both sides by this denominator, and then we're going to divide by f prime, x1. And so the next line, just by some algebra, is going to be the opposite of f x sub 1 divided by f prime x sub 1 is going to be equal to x2 minus x1. And what are we trying to solve for? We're trying to solve for x2, right? We want that next guess. Okay, so to solve for x2, we're just going to add x1 to both sides, right? And so we get this equation. We get that x1 minus f at x1 divided by f prime of x1 is going to be equal to x2. Now hold on to this, and let's compare it. So I'm going to zoom out just once, so that way we have enough room. And look at these two equations, or these two iterative methods. All we're doing is we're just using the previous guess, and we're plugging it into a formula. And that's what Newton's method does, is it just keeps doing this process over and over and over again, right? And so we have a general formula for Newton's method. And the general formula that we're going to use is the next guess. Okay, so this is our next guess is going to be equal to the current guess, which is xn, minus f at xn divided by f prime at xn, where xn is the current guess. Right. And so this is Newton's method, our general formula. Right. So now, I'm not going to ask you to be able to derive Newton's formula or Newton's method for an examination. We're just going to be able to use it. All right. But since it is an application of the derivative, I wanted to ensure that everybody understood where this came from. All right. And where it comes from is just the continuous tangent lines that are going to be associated with the function and then the next guess and the next guess. Right. So in the next video, what I'm going to do is I'm going to show you two examples of using Newton's method. How are you going to use it? Where to put the xn plus 1, the xn, and all that stuff, and then how to plug it into your calculator to make it really nice and easy for yourself.